humans are really bad at making things random. People can actually use statistics to figure out whether someone has fabricated information or not. The reason is that data, naturally, if it's random, will occur in kind of clumps. Humans like order though, and so if I was to ask you to create random dots on a piece of paper, you would actually make a smooth looking distribution of dots. You wouldn't have them clumped together, and that is not random. So something that is really close to this is called the birthday paradox. If you put 23 random people in a room, what are the odds that 2 of those people, any 2, will have the same birthday? 50%. About 50%, a little over 50%. This seems like a contradiction because there are 365 days in a year. So let's do some math. To make it easier to understand, think about a week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. If I was to think about the probability of 2 people having the same birthday, let's call that n equals 2. First, let's figure out the possibility that they wouldn't have the same birthday together. And I'm going to call that P bar with 2 in there. Again, that's the probability that these 2 do not have the same birthday. So let's pretend that we could actually pick our birthdays. The first person would actually have 7 choices. So they would have 7 out of 7 possibilities to choose from. The second person though, if they were choosing randomly, what is the probability that they would not share that same birthday? So pretend our first person picked Sunday. The second person would have 6 out of 7 probability of not having the same birthday. That is actually going to be 6/7. So the probability that if you put 2 people in a room that they would be born on the same day of the week, that would be the opposite, or 1 minus this probability. So the probability is actually 1/7. So let's start adding more people. What if we had 3 people? So again, we're going to figure out the probability that 3 do not have the same birthday, and then we'll find the opposite to see if 1 or even more of them have the same birthday. The first person has a 7 out of 7 chance of not choosing the same birthday. The second person would have 6 out of 7 chance. The third person has 2 less options, so there is a 5 out of 7 chance. So if we multiply this together, this is 30 out of 49, working all that math out. So what is the probability that 3 people in a room would share the same birthday? 19 out of 49. This means that 2 of them could share the same birthday, or 2 of the others, or 2 of the others. There's 3 ways to pair them, or all 3 could be sharing the same birthday. The odds of one of those happening is 19 out of 49. If you calculate it, that comes out to be about 39%. But it makes sense. If you put 4 people in a room, it's more than half of the days. So you would think, well, probably 2 of them at least have the same birthday. So how about for a year? The probability of not sharing the same birthday for 2 people. Well, the first person has 365 out of 365 days. We're ignoring the fact that you could have leap years. And then the second person would have 364 out of 365 options to choose from. In total, 364 out of 365. What's the probability that they actually do share the same birthday? That would be 1 out of 365. And this fact right here is why people are so surprised by this paradox, because the odds of me and you having the same birthday are 1 out of 365. But now, let's go on here. Let's find the probability of not sharing the same birthday with 23 random people. 23, this will be 365 all over 365. And we're going to multiply down now. So this would be 365, 364, 363, and underneath each of these, we're going to have 365 in the denominator. ... We're going to have 23 of these fractions. So the last fraction is going to be 343 over 365. So there are 23 of these fractions. Now, to do this on a calculator, you could crunch it all out. I have a little shortcut. It's actually, if you know what NPR is, I'm actually doing this in my calculator. And on the bottom is 365 to the 23rd. That P there means you have 365 and you're going to multiply down 23 numbers counting down. I get an answer of 0.4927. What this is saying is that if I put 23 people in a room, there's a 49.3% chance that none of them will have the same birthday. So the probability of actually having the same birthday is 1 minus 0.493, and that comes out to be 0.507. There is a 50-50 chance that if you throw 23 people in a room, they will have at least one pair will have the same birthday. And so I've tried this with my classes. I actually, when I teach this in high school, I just go through every class. And because I have like 35 students in a room, the odds are actually more like 80%. But it turns out that almost in every class, I almost always end up with people with the same birthday. If I have 200 people watching this very video, I'm gonna have, for sure, at least one person who will have the same birthday. My birthday is December 9th. If you have the same birthday, you should reply back. So how can I be assured to have the same birthday? Well, there's always that slight chance that for some reason, the birthdays spread out perfectly within a year, and we have 364 birthdays that don't line up on the same day. But to really assure that you have two people on the same birthday, you need to have 366 people in a room. That's called the pigeonhole principle. If you have 365 days and you have 366 people, at least two people have to share the same birthday, at least. So here's a simple question that you can ask yourself that might help you in Yahtzee. Let's say that you have 5 dice, and you're gonna roll them at least 3 times. What are the odds that you will get at least a 3 of a kind? Hope this got you thinking. If you like what I'm doing here, please subscribe.